Hello.
Hey, Lori.
Hello.
Oh, can't hear you.
Let's see. Should be working.
Still can't hear you.
I can hear you.
You can hear me?
Let me see. Check.
Hey, Rob. Welcome.
Hey, am I unmuted?
I can hear you.
Maybe
There we go.
maybe I'm the one who can't hear anybody.
Yeah. Andrew's the one who can't hear anybody.
All right, I'm going to try something.
Do these usually have an agenda or anything?
Pardon?
These Hangouts or meetings usually have an agenda or a speaker? Or...
Yeah, usually there's a speaker pre-announced. I missed it if somebody said what that was this time.
I missed it too.
All right, I can hear this time.
Yay!
Awesome. Welcome back.
Thank you. Rob, I'm not sure if I've met you yet.
No, I don't think we have met. I decided to just show up and lurk and see how the meeting goes.
Yeah, that's fine. Hey, Tom.
Hey, how's it going?
Good. How are you?
Good. Happy to be here.
Happy to have you.
So, Andrew, you're in Portland, and you're running the Portland Ruby group for a while. Is that?
I am in Portland, and I am running the Portland RubyMotion meetup. And we'll wait just a few more minutes. But while we're waiting, I thought I'd ask if there's anything that people are particularly interested in learning about or hearing about. The thing that I've got on my agenda to talk about is building tile maps with motion game.
That sounds good.
It's something I've been interested in and thought now would be a good time. How about you, Rob? What is your RubyMotion experience?
I've gotten it installed.
Nice.
I've made Hello World. I've dropped a little table view and filled it with junk.
Sweet. Where are you located?
I'm in Oklahoma City.
Okay, cool. Tom, I know you're relatively new to RubyMotion, but you've been diving in head first.
Yeah, I've been tinkering around, trying to see how all this magic is put together. So it's been fun to kind of do some basic stuff and see what other people have built. So it's pretty neat. It's a nice community, pretty active group of folks. So it's been fun to hang out on the Slack and see what folks are talking about, and so interesting stuff.
So it looks like Motion Games from HipByte, and is it actively maintained, or is like, I guess I'm not really sure where HipByte's at as an organization.
Right. So HipByte used to be the company running RubyMotion, and so that's kind of why it was under HipByte. And I'd say it's been relatively inactive the last few months, but prior to that, it was relatively active. So I'm not sure how involved Watson is anymore, but there are several of us who are interested in game development in Ruby and RubyMotion. So we're interested in moving things forward. I know I am.
Got a lot of familiar names on the commit history for it.
Yeah.
Don't know. Did Andy say he was not going to make it tonight?
He did. He sent me a message saying he was going to make it.
Okay.
Have you all gotten to know Amir? Has he showed up for some of these?
He's been to the last 3, I think.
Oh,
Yeah.
good.
Yeah, last time we had quite a bit of a mere Q&A.
Yeah, I bet a lot of queues going around.
Yeah, I think he said he was going to show up for this one, but he doesn't seem to be online right now. So.
Oh, we can get started.
Sure.
Let's see. All right. Going to presenting to everyone now. I think that means that it's on my screen. Okay. Motion game, if you're not already familiar, is this gem that's available for RubyMotion that allows you to write cross-platform mobile 2D applications or games for iOS, tvOS, and Android. It is built on top of Cocos 2D, which is a cross-platform C++ game engine, game library, and Box 2D, which is the physics engine. And Motion Game, just install it as a gem, and then you can generate a game with Motion Create, specifying a template Motion Game. So at this point, the repository that we've been building on top of a bunch of examples of how to do things in Motion Game. And you can find it on github.com/andrewhavens/motion-game-examples. And I need to update the README here, but the app provides several different examples of how to do things. And as we learn how to do more things, we are adding more examples here. So the first example is just tapping on the screen and drawing dots. So wherever you tap on the screen, you just draw some randomly colored dot of a random size. And then there's an advanced example where you have to tap the dots before they fade away to get points. And then the next example is a walking sprite. So walking around your little character by tapping on the screen. And some collision examples, so running into other characters or running into something good like a coin to pick up. These are examples in here. And so something that we haven't gotten to yet is how to draw a map, basically the background behind the character that's moving around. And so the terminology for this sort of thing is called a tile map. Tile map is basically an array of tiles, like images. So the sort of the most basic way you could achieve this is to have an array of IDs for your image. And then you iterate over your array and draw each one. But managing an array of image IDs would get kind of tedious. So there's this thing called a tile map file format. In particular, the tile map format that Cocos 2D supports is TMX, which comes from this app called Tiled Map Editor. And just realized that having a conversation about motion game in RubyMotion Slack right now. All right, sorry. So this tiled app is a open source tile map editor that has its own file format, TMX, which is basically an XML file that that has all the information about the tile map, all the different tiles in your tile map. So basically, a bunch of sprites contained within a grid, and they're all images that are reused. So the first thing that we want to do is open up the tiled app. And let me just close these out so we can start from the beginning. When we get to tiled, we can create a new tile map. And the options that we get are orthogonal or isometric, staggered and hexagonal staggered. I am vaguely familiar with the differences between orthogonal and isometric. Basically, the way that 2D games are rendered, the perspective. You think of like an RPG style game where it's a fixed perspective, but it's not like fully three-dimensional because they're the things in the distance aren't smaller; they're still the same size. Let me see if I can show an example here. So this is an interesting visualization of the challenge of isometric perspective. It's that it looks like these connect, but this is actually going up higher here. But things like Zelda or some of these old types of games, you can see there's like one perspective and so each of these, this map is made up of individual tiles here. So there's no dynamic resizing of the perspective here. They're all the same size. So we're going to build one of these types of maps. We're just going to try to start simple here.
So this tile is just a free open source tool?
Yep.
That's pretty cool.
So it's basically like this TMX files, this open standard type of thing. So there's a lot of libraries that support this TMX format. I'm going to change to orthogonal. I think this is what we want. All right, so one of the first things we want to do here is add a tile set to our map. And to do that, we want to click a new tile set based on an image, or we could do it, or a collection of images, but I've got a sprite sheet here that I can use. And the margin and spacing will matter if you're importing a single image and all the images are spaced out a certain amount. You know, sometimes they'll be spaced out by 1 pixel or whatever. But we set our tile width of 32 pixels and save it. So this tile set is also it's basically a separate file that gets referenced by this tile map. I'm just going to call it demo also. So here's our tile set that we just imported. And oops, we've got all these individual tiles here to work with.
Is that going to kind of work like a sprite sheet?
It's basically a sprite sheet, yeah. It's a sprite sheet that we're going to reference in our map. So we could just start picking some stuff and start drawing our map here. I'm not going to put a lot of effort into drawing this, but we'll try to do something interesting. One thing I noticed about this tile map was that, this tile set was that there's a transparency to these images. So let's say I pick one of these because I want to create an edge. But it basically fills up this whole space here, the whole tile, but there's an empty spot, like the transparency isn't working. That's because we can't have a tile that takes up 2 spaces, or 2 tiles within 1 space within the same layer. So that's when I learned about layers here. So first layer in our tile map is going to be grass. We're going to add a new tile layer, path, and now we're going to be drawing on our path layer here, and it overlaps the other one. Oops. You can toggle it on and off to check it out. Oops, wrong layer. Did I click on the layer you want? There we go. Okay, so we've got our grass layer and our path layer. I'm just going to save this file. And now we have a tile map. And the next thing I want to do is load up my motion game examples repository here. I'm going to clear all this out for now. Actually, before I do that, I'm going to show you the motion game code base first. So the motion game gem code base. Motion game gem code base has a lib directory which has some Ruby files in it, but most of the code is actually in this source directory, which has a bunch of C++ files in it. So basically the C++ files here provide the mapping between the Cocos 2D code and the RubyMotion code. So normally you don't have to do this sort of thing, like with if you're building a RubyMotion app and you want to just add a CocoaPod or something like that, you can usually just reference that directly. But this C++ code, we have to sort of create a mapping between the two. But it also lets us expose our own API this way. So when I started trying this out, I realized that that Motion Game hadn't yet supported tile maps. So I'm a total beginner to C++, so I could be doing some of this stuff wrong, but I am imitating what I've seen here in the code base. The tile map works similarly to Sprite in that it's a subclass of Node. So I started by initializing this new tile map module, like setting up the tile map class and going through and setting up the bindings that we needed to support this. So I set up this tile map load method similar to mgsprite.load, which you would use to load a sprite, actually a sprite sheet. In this case, we want to load the tile map. So here's the Cocos 2D code where we take this TMX tiled map and we create it with this file name that we specify. And then we return this new RubyMotion object here, which represents a tile map. And we've got a few other methods that we can work with here. You can access the layer or the tile size. And down here at the bottom, this is where we initialize the tile map class, and we specify that we want to create a tile map in Ruby on the Ruby side, and that calls our we've got our singleton load method here and our instance methods, layer and tile size. So now in the gem, I can run rake build iOS to build the iOS bindings that we're going to need for that. And I've already done it recently, so there's no output. And in the motion game side, we've got our new tile map example here, which is a tile map example class. We're just adding this option here. And let me show you what that looks like. So we can run bundle exec rake in our motion game examples project to launch this. I have a few versions behind here, but that should be fine.
I think we all feel that pain when you see that update. And it's just like, but everything in my app is working. I don't want to update.
Yeah. Anybody have any questions so far? All right. So here's the examples app that I was talking about. I can just show you some of these examples. Animated sprite is just shows an example of how to animate a sprite. Basically, to run an animation of multiple images. Walking sprite, this is one where you can actually tap and have that character walk around. And my computer's having a hard time streaming and running this code at the same time, so it's a little slow. It looks a little slow, but it's not. Doesn't actually run this slow on normally. So our tile map example, right now it doesn't do anything. It just loads this back button. So now in our tile map, oh, and I'm referencing this gem locally to specify my local path to motion game because I'm actively making changes to it. But the first thing we want to do here is load our tile map. And to do that, we can use mg tile map load and specify our mo.tmx file. I didn't actually put that there. So I'm going to copy it over. I'm going to copy the tile map file and the tile set file. Copy it into all right, let's see if this works. So when we do that, we're going to get a tile map returned. And just by doing this, we're not going to actually see anything, even though it'll be loaded, because we need to add the tile map to our scene. Let's try running this again. Oh no, it crashed. There's one other thing that I'm missing here, and I think it's that the tile sheet is referencing. Oh. Is this even today? I don't think this is right. I think I need to copy over the so I copied over the demo TMX and demo TSX file. I think I actually need to copy over the image that is used in the tile set also. So I'm going to do that real quick. Okay, what changed? Got another tile map that was working here, so I'll try that next. There we go. There's something wrong with my tile map, I guess. I'm assuming it's some sort of configuration. But I can open up this one and check it out. Tile layer format CSV. Tile layer format base 64. Interesting. Let's try changing that. Base 64 zlib. All right, save that.
Is that the one in your resources directory?
You're right. I copied it instead of actually moving it. Let me close these. Open up the one in my resources directory. Yeah, that's why.
That could be the problem.
So it's relative to, I don't know why I couldn't find it because it's here. But I'm going to try to find the one that's relative to my project here. Train.
That looks better.
It is working now. So maybe the tile layer format doesn't have anything to do with it. But we will see here in just a second.
Or maybe it does.
Hey, okay. So it doesn't like CSV format. Good to know.
Good to know. Or there's something extra that needed to be implemented for that to be supported.
Yeah.
So say, how can something not like CSV format?
Yeah. Yeah, that's must have left something out that I needed to. All right. So one thing that I noticed is that it looks a lot smaller here than it does here. And since tilemap is a node, we can just do tilemap dot scale equals 2 to be double scale. And that should make it bigger. Actually, while we're doing this, I'm gonna set tilemap as a global variable here so that we can access it from the REPL. So we can play around with it without having to rebuild every time. So there it is, double size. Another thing I just realized is I didn't put anything in the corner, but I'm pretty sure it's starting in this. It's rendering it from this corner down here. So we're getting the bottom part. I think it's rendering it from the bottom corner up. I did just command click on there and I get reference to tilemap. And I want to do just play around with this self.scale.
Self.
Apparently, they don't have a reference.
You had the reference. You made the reference. Dollar tilemap.
I'm not sure if I rebuilt since then.
Oh, okay.
I've seen in documentation stuff how in RubyMotion you can do reload or some other command, and I feel like that crashes a lot. Is that everyone else's experience to just like exit and rebuild rather than trying to reload stuff?
Amir has new reload stuff. There was some stuff that broke some of the reloading, and there's a little video and some code snippets that you can use to do reloading. That's a little bit more better.
In your opinion, is it worth it or not?
To tell you the truth, I mostly do the rebuild, but my app is not sort of, I don't know, conducive to do, like there's times when you're trying to tweak something that it's really handy, but there's other times where you need to actually go in and make more advanced changes, and then you're just back to rebuild. So, depends on circumstance, I guess.
when I was doing some app development that had a lot of styling to it, it was very helpful to enable some live reloading and tweaking the styles to get things to look just the way I wanted them to. But for more logic-based development, well, from that I usually try to do a test-driven development kind of approach to it. So write some tests first, run the tests.
Have the tests fail, then give up for the night.
For me, it's more like hammer away at the tests, have it fail, 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 and then go and run the code, and it works anyway, even though the tests fail.
Been there.
Wait, he ran away.
He fell because the way I've got this set up here, this is inheriting from this other code that we were using, where hero is dynamic equals true. I think that means it adds the physics to it. And it inherits from character, which does attached physics box. I guess that's really what it is. And since it does that, it gets some gravity by default. But in our environment here, this isn't a platformer type of game that has gravity. It's like an RPG style game where there isn't any jumping involved. So we need to add a line to turn off the gravity, which is gravity equals 0, 0. I'm not sure what 0, 0 means exactly, but I know that turns it off. The other thing that this won't do yet is our hero won't walk anywhere because we aren't responding to any touch events. So we're going to want to do an onTouch begin, do event, and our hero walk to the event location. Oops, I double clicked, so I started walking. All
Cool.
right, now our character is walking on some terrain. One of the things that I realized, the next thing I was going to want to do is have the character walk in a world that goes beyond the bounds of our screen here. So I was trying to figure out how to do that. And the first thing I realized that we're going to want to do is have the terrain move as we tap near the edges here. So we can just start by updating this code here to take our tile map. And we're going to want to move our tile map basically at the same speed that we're walking. So we can, since it's a node, we can call run action on it. And we're going to use a mg move to action. We're going to initialize this new action with the location that we want to move the map to. And in this case, when we tap somewhere, we want our character to move there. But as our character is walking, we want our map to move the opposite direction. We want it to move the opposite direction that our character is moving. So this is going to be the location that we want our map to move. This is where we want it to go. We're basically repositioning our map on the screen. Right now it's at 0, 0. It's down here. But we want it to be dynamic and move. So we're going to take the event location x coordinates, and we're going to multiply it by -1. So we want it to go the opposite direction. Event location y in the opposite direction. Now this move to takes a speed or a duration of how long it should take to move this. And we can see in our character, our hero character, actually, our character over here, we've got this walk to method that we wrote to perform this animation, and we pass it the location. See, we take this tap location, we pass it in to walk to. Walk to takes that location, figures out if they're moving to the left or to the right, and we just flip the sprite horizontally. So right now this sprite is not very smart. We just have a walking left animation and a walking right animation. There's no walking up or down. It's just left or right. So, but we calculate the duration, like how long it will take to walk to this location, so that it's not the same every time. When we first started doing this, we were like, well, let's try just taking a second to walk there. Well, if they're walking all the way across the screen, then we don't want it to take 1 second. We want it to take, we want it to go at a constant rate, a speed. So we take our, we calculate the time to walk to the new location by taking the distance of the new location to our current position, and we divide that by 150. Just a number we came up with that looked like the right amount of time. And I extracted this out into this other method, so we can use that method to figure out how fast we want to move our map. We can use our hero time to walk to event location, and this will give us the how long it'll take to get there. So then we'll pass that in here to duration. And then we call this move action. And then now we will move the map as we're walking. And we will soon see that this is not adequate for a real game, but it will get us in the right direction.
I need to peel off for the night. Thanks, everyone.
Sure, yeah. Thanks for joining us.
Bye, Rob.
What's the current time where you guys are right now?
It's 9:30 for me.
Okay. What about you, Tom?
Yeah, I'm in Minnesota right now, so 10:30? Yeah.
Gotcha. Hey.
Woohoo!
Our character's moving. The problem is that this doesn't really solve our problem, because now we're going twice as fast. It looks like we're going twice as fast to move to this location because we're moving our character and we're moving the map. And what I really want to do is make it so that if you're walking around in the middle of the screen here, the map doesn't move. But if you are near the edges, if you're trying to go near the edges, then the character looks like it's moving, but it's really just the map that's moving. So this gets a little bit more complicated here, because we would want to check where on the screen there where the user has tapped. And if it's within kind of a middle area here, we just move the hero. But if we are if we reach the bounds, we need to stop actually moving the character, but continue the animation. And I'm not even sure if this logic will work right here. But we can try it out. Let's see. The other direction we can go with this is trying to interact with the elements on in the map. So this is another cool thing about this map format, is that we have access to these layers. So for example, if if the character is interacting with one of these tiles on a different layer, we can provide some collision detection there. Or let's say another thing that we can do is add some metadata to these tiles, the type of tiles, or the metadata for the, like where on the map the user should spawn. So there's some interesting things we can do there. The only challenge there is that the support for that right now in Motion Game is, right now we can get the layer by specifying the layer name, and we can get the size of the tile for information purposes. But other than that, we'd need to add a little bit of support to be able to fetch that information from the map, which might not be too hard to do. Here's, I'm not sure if I went over this, but the way that I started going down this path of adding these methods, these classes and methods to Motion Game, is that I looked in the Cocos 2D API documentation here, and I saw that it had a get layer method. Well, first I figured out what a TMX tiled map was. It said it inherited from node. There's information here about like where the anchor point is, and the some different information about that. But when you get a layer, you get a TMX layer returned, which has its own methods on there. You can get properties, you can get a tile at a specific location. So lots of different interesting things you can do there. But I think maybe the most interesting thing to do right now would be to figure out how to get this character to stay within this middle area here. And only have the map move.
I just got to step out for a moment, but I will be back.
All right. So we've got this thing called a director, which is basically in charge of all the scenes and everything. From the director, we can get the size of the screen. So we can figure out what the boundary is going to be. Say like the left boundary is going to be make it 200 from the left. The inner boundary on the right is going to be the screen width minus 200 pop. I'll also make it screen height minus 200. The bottom is going to be 200 from the bottom. It's 0. So let's just check if the first let's check if the touch is within the boundary, which is going to be that location X. Is greater than inner left and that location left is less than inner right. So within X boundary and Y boundary is going to be yep. Top. All right, let's just put
Now, will this also run on tvOS with no problem? Or I guess Android also?
it should. Now I don't know if the work I've done to Motion Game to add support for tile maps is working correctly or not, because I've only tested on iOS, but Motion Game itself and Cocos 2D should run on tvOS and Android. All right, we're within our boundaries. Go up here. Not within our Y boundary, because we're up above here. About over here. Not within our X boundary. Not within our X boundary. Not within our Y boundary. Yes. All right, well, that part's working. So I feel like at this point we need to separate out the walking animation and the actual moving the character. Got this fix me note in here to use a sequence instead of delay time action. Well, I guess I'll have to do that some other time. So this run walk animation is pretty much self-contained here. This is when we interestingly accept a block here. Not sure what we were planning to do with that. Maybe that was a callback. Oh yeah. Call after you get there. Oh. Don't need that right now. What we need is to be able to we've already got this, so I think it's going to get tricky. The tricky part about this is that we're not discerning between whether or not you're starting within the boundaries or you're going out. So if you start in the middle here and you go all the way to the end, it should stop within the boundaries, but the map should continue moving. And I don't think that our event handler is going to be able to help us much with that because we're just checking on the on touch begin. I suppose we can just move to the boundary. That would work. All right. So we're going to stay within our boundary. We just want the character to walk there. We're not within our boundary, so if we've gone way outside here, we want to walk, go to boundary. We want to animate moving map. We've reached boundary. Continue animation after reaching boundary. So this part's going to be a little bit more complicated. For now, we're just going to move the map instead. And display the walk animation. Yeah, going a little slow right now. All right. Here's our character. We are moving within the boundary.
Boom.
Oh. What did I do wrong? Undefined local variable method block for hero. Oops. Oh, the block is down here.
Carpassian block.
So we could run an animation after we, or run a callback after we run the animation.
Looks good.
There it goes. What did I do now? Walk 2, wrong number of arguments. 2 for 1.
Walk 2.
Where did I wrong here? After 28. I think I added that later.
Oh, did you build it before you added that second parameter?
Yeah. I did. I can never remember if I have to put an ampersand before the block in order to pass it as a block or not.
I can't either.
It's still 28. Yeah. 28. There we go. All right, we're within the boundaries, so we're moving here. Now, click up here. Whoa! So our character is correctly walking. Playing the walk animation. The not facing the right direction because the flipped horizontally logic is within the walk to method, which doesn't feel right. But for now, So here we can run our walk animation for the full duration, but we only want to walk to the boundary, which means we want to move to hero.move to our new location modified, our new location boundary. Basically want to get to the, if we're within the X boundary, then we can use the X location. If we're within the Y boundary, we can use Y. Okay, I'm going to split this in X and Y again. Then X boundary wait, new location. We don't even have new location yet. New location doesn't really make sense here. So change that to event location. If event location.x, if we're within the X boundary, we're going to return event location X. Otherwise, we're going to use our boundary. But we don't know which side it's on. If our event location X is less than our inner left. And we know it's outside that boundary, outside of our left boundary. So let's say event location X is 0. Our left boundary is 200. You want to stop at we want to stop at the boundary. We don't want, it doesn't matter. If the location is greater than our boundary, then we were boundary. Otherwise, Event location is fine.
You missed that Y. There's an X there.
There it is. Thank you. Actually, I think that's the easy part. All right, let's try that. So after all this logic, we should be able to move our character to the boundary or somewhere inside the inner boundary that we tapped on and run the walk animation for the whole duration. And the map is just going to, we're just going to ignore the map for now because it has terms of its own. And I have a feeling that there's a way to clean this up so there isn't, so this code doesn't look like this. If you've got any ideas, feel free to suggest them.
You could use a case statement, but it's not going to make a big difference to how ugly it is.
All right, moving inside the boundaries. We go outside the boundaries. Uh-oh, we crash. What do we do? Wrong number of arguments again. What is this?
46.
Line 46. Oh, whoops. I need the duration. Ah, yes, this is the hard part that I was thinking of. So not exactly sure at this point how long it will take for us to get to the boundary. Actually, we might be able to check that. Time to walk to new location. Yes, okay. Let's try that. I'm not sure if it will take this array style argument, but we can try. Hero dot time to walk to and move location. try it. The thing I'm concerned about is that this array style argument, which basically represents a point, we can pass that to these methods like move to, because I think it's smart enough to treat it like a point, even though it's an array of two things. And I don't think this method that we created is going to work. Although distance might be a method that's smart enough to take that. But we'll see. All right, clicking outside the bounds. Hey.
Hey. Something funny about that top stuff.
Interesting. All right, so character sort of seems to be animating and walking as we expect. We're continuing the animation even after reaching the boundary. The map. We only want to animate moving the map once we've reached the boundary. And that's assuming, and this is going to be related to this stuff up here too. I feel like there's going to be some duplication. If we are within the bounds, we don't move the map. I'm going to expand these a little bit. So instead of saying within X boundary, we'll say within left boundary and top boundary. This is actually within the right boundary. I forgot to ask, is this font size okay for you, or should I increase the font size?
No, it's fine.
Okay. So if we're not within the left boundary, I'm going to want to move the map to the right once we reach the boundary. Is that right? So that means if we click somewhere over here, once we reach the boundary, we're going to start moving the map to the right. Else if not within right boundary, I'm going to move the map to the left. And that'll be our X. Actually, if we're in the boundary, then we don't need to do anything.
Yeah, we're not going to get here because that's in the other part of the if.
Well, technically this if only applies if we're completely within the boundary. But if we're in, let's say we're within the X boundary, but we're not within the Y boundary, then we need to do something a little bit different. Well, we'd need to move the map on the Y-axis, but not on the X-axis.
Mm-hmm.
And also, if we're not within the left boundary, we didn't click over here, we didn't click over there, we clicked somewhere in the middle, we don't need to move the map, but that doesn't, we don't need to move the map on the X-axis, but that doesn't mean that we won't need to move the map on the Y-axis. So I'm just going to add another else to set the as event location X. Actually, no, it's going to stay the same. I think what we want is the tile map position. Tile map position X to keep it the same. And if we're in the top boundary, not within the boundary, because no matter what, we're going to need to move the map. That's the reason why we got here. We're either moving it in both directions or we're only moving it in one. New map. not quite going to be like this, but we're going to be moving to our new map X and our new map Y. And the thing is, we don't want to do this right away. We only want to do this once we reach the boundary. So we need to figure out how long will it take until we reach the boundary. And I think we know that because we figured that out up here. Figured it out. The hero time to walk to the new move location. Which is outside of our boundary. Okay, let's see. Just put that in there. Actually, how long it will take time to boundary. That's not how long we want to move it. That's when we want to start moving it. So we want to delay this time to boundary. On action delay time on the tile map. We wait until we get to the boundary, and then we're not doing any walking animations on the tile map. We don't need to do this. What we do need to do is move this. But here's when we need to figure out what the duration is going to be. So I think we need to take the total duration and subtract the time that we are going to take to get there.
Yeah, that makes sense.
Which is going to be...
You've already got the duration.
Duration.
Yeah.
And in this case, let's call it total duration. Total duration minus time boundary equals our move duration. All right, so this should work once we get there. We just need to figure out what the new map X and new map Y is going to be. So we basically need to figure out what distance we've traveled in the map. And if we're in the middle here, our character is moving in the map. Let's say this is 100 pixels, 100 points on the map. But let's say we go twice as far. We go 100 points we stop animating, but then the map needs to move 100 points more. So that is going to be the excess. The excess event location that we took off of the new move location.
So the difference between the event location and the new move location.
Yeah, I think so. Let's try it. Let's start with the left boundary. I think that'll be easier to new map X equals the new move location X and location X. That's right. Let's see. If I tap out there, it's going to be a lower number than the boundary. It's like 200. This is 100. We're going to move an extra 100. So 200 minus 100. So new move location minus this location. So that should work. And for on the right side, this is going to be a higher number. So we just want to swap these. All right. I'm going to do a similar thing down here with the top boundary. Top is going to be a higher number. So it's first. Lower. All right, moment of truth. See if it works.
This is an example of where I'd rather be doing test-driven development.
Yeah. In this case, waiting for it to build to be able to click around. And one thing where I'd want to have a test to ensure that I don't break it in the future. Okay, move here. Oh,
Nope.
almost. I just went the opposite direction.
Went the opposite direction. Gotta flip those around.
Okay.
That was for the Y stuff, right?
Yes. So it's opposite in both directions. So I think we do need to swap these because we don't want a positive number. We're not moving at a positive number. We're moving at a negative number. Something's not working right here.
Yeah, the X one, the Y one is definitely moving in the wrong direction.
Let's start over here.
So you want the map to be moving down, and it's moving up.
Yeah. So we'll start with Y. So we tapped above the top boundary. So we're not within the top boundary. So swap these.
Yeah. Is this one of those cases where we're getting messed up by where 0 is?
Probably. Doesn't move that much up in that direction though, which is a little strange.
We should have just swapped these lines around, but whatever. Okay.
Well, let's try that and see if it works.
I'm gonna have to bail soon.
Yeah, me too.
Yay!
It works pretty good, except if I keep tapping at the top, it doesn't keep walking. So I'll need to figure out what's going on there. But let's see if this works. It doesn't work either. Well, we're close.
Yeah.
That part worked. That part worked. As long as we're not going too far, it works okay.
Or close.
Yeah. Probably a good homework exercise. Try to figure out where we went wrong.
Okay, I'm going to have to pack it in. But thanks a lot for working through that.
Yeah, thanks for joining me.
Yeah, I just realized it's 11:30 here, so I did say.
Well, I hope you, hopefully you guys learned something and enjoyed working with me on this.
Sure.
Yeah, it's pretty interesting to see. Thanks for sharing that. I've been digging into the gem a little bit, kind of learning where things are and how it's organized. So it's been interesting. still trying to get some methods out of the RubyMotion VM. So it doesn't quite have like the same C interface as like other implementations. So that's been kind of interesting to see what's exposed and what's not. So
yeah,
I don't know.
Cool. Well, I'd like to see a demo of Ruby 2D running on RubyMotion soon.
Yeah. If I had a couple, can I share a screen real quick? Is that like a hard thing to do?
Yeah, you could.
Do I have to be like a moderator or something?
No.
Just
the button's not working.
The green button?
Icon on the left side.
I see the green button, but it doesn't work. Dang. It just doesn't do anything.
Really? Because mine's letting me try.
Let me just reload real quick.
Yeah, I just got new Apple TV to use as my development device.
Oh, nice.
Oh, now it works. There's a 5-second demo. This is running on do you see my screen? Is it showing?
Yep.
Oh yeah. So this isn't running on RubyMotion, but rather just whatever. This is a little I don't know if you ever messed around with celestial physics, but this is an N-body simulator. It might be really laggy, I don't know, but you'll see the stars moving around and they're all attracted to each other by gravity. So it's it's all written in Ruby there. So
that's cool.
And it's about 91 lines, so and it's pretty performant. So anyways, I'm just like messing around with that stuff and trying to implement I've got this massive PR to add it in my native graphics engine. I'm going to merge this thing tonight. I'm just going to squash everything, which you've commented on. Some motivation there. And then instead of Cocos 2D, I'm then using this as basically kind of the native engine and kind of so Cocos 2D is huge, just like supports everything you'd imagine. So I'm just kind of implementing just sort of some of the essential things, and that's just wrapped by this gem that I've been working on for a little bit. So,
and then your simple 2D is built on top of SDL. Is that right?
Yeah, and SDL is basically like just a layer on top of every operating system, basically, to just like give a consistent interface. So if you want to create a window or just get a context for OpenGL rendering, it just exposes a common API to all that stuff. So, but that's it. So it doesn't do anything else. And then, and then I've kind of abstracted it a little bit higher so you can do even simpler things. Like you can see here, just like, this is in C, but it just create window. And this works on the Mac and Linux and Windows and iOS and should be in Android, although I haven't tested it yet. And then just, so it's a lot simpler. It's not going to have everything that Cocos 2D has. Like implementing a tile parser is probably not something I'd want to do. But, you can achieve a lot of those effects by just kind of figuring out what you need and kind of finding the shortest path to do some of those things. I'm trying to create trying to rethink what an API would kind of look like. So I've got some documentation that isn't quite done yet, but just trying to think about what some of those things could be. I don't think I have a sprite on here yet, but really pretty simple examples of. So anyways, yeah, all this should work on RubyMotion, but I'm still need to get those. Stop sharing.
It's okay.
Oh gosh. Oh, I'm stopped. Okay. Yeah, I just need like a couple functions that are all available from the C interface on MRI and also mRuby. I want to ask Amir about a tough question about just like, is it sustainable to maintain an entire Ruby VM that's implemented just for kind of iOS devices, or because mRuby or nothing like that existed. You couldn't compile Ruby applications when RubyMotion came out. So I wonder if some of that would be worthwhile thinking about, like if mRuby would be a viable choice to kind of replace some of those compilation things. So might be interesting.
Yeah,
that could be another topic. So
yeah.
Cool. All right.
Okay. Well, thanks and good night.
Yeah.
Take care. Bye.
See you next time. Bye.